Hey guys, we're going to continue with matrices now. Today we're going to start with multiplying matrices. When you multiply matrices, you multiply rows by columns. So you're going to multiply the first row of the first one by the first row of the second one, then the first row by the second column. I think I said row for that one, but it's column. So it's a row by a column, and then that same row by the next column. When we multiply matrices, we've got a 3-row by 4-column matrix, and then we've got a 4-row by 3-column matrix. And I know that I can multiply these because the inner dimensions match. And it's the outer dimensions that tell me the dimensions of the product, 3 by 3. So I've just got a matrix here with variables representing each element. We're going to turn those variables into numbers. But I've got a 3 by 4 and a 4 by 3. Inner dimensions match, so I can multiply. Outer dimensions tell me 3 rows by, and I put a 3 here, but that should be a 2, by 2 columns. This is 4 by 2. So I've got a 3 by 2 set of outer dimensions. That will be the dimensions of my product. Okay, so here's how we do this. We are going to multiply this first row by this first column, one element at a time, and we're going to start with the first elements, 2 times 6. Okay, then we're going to move over and down, 4 times 0. And then over and down again, 1 times 1. And then over and down one more time, 3 times 2. Okay? And I'm going to add that all up. So I've got 12 plus 4, which is 16, plus 1, which is 17, plus 6. I'm sorry, I've got a 0 here. So this is 12 plus 0, which is 12, plus 1, which is 13, plus 6, which is 19. So that element A is 19. Okay? Then I'm going to multiply that first row, that same first row, by the second column. So I've got 2 times 5. 4, so I go over and down, 4 times 2. Over and down, 1 times -3. Over and down is 3 times 1. And I'm going to add that all together. So I've got 10 plus 8 plus -3 plus 3. And that is a total of 18. So this second element is 18. So now I have multiplied the first row by the first column and the first row by the second column, and I'm all out of columns. So I'm going to move down to the third row. So the third row by the first column, 1 times 6. Over and down, 3 times 0. Over and down, 2 times 1. And over and down, -1 times 2. Okay, so I've got 6 plus 0 plus 2 plus -2 for a total of 6. So my next element is 6. Okay, now I need to do that same row by the next column, 1 times 5. 3 times 2. 2 times -3. and negative 1 times 1. So that gives me 5 plus 6 plus negative 6 plus negative 1, which is 4. So my element here, D, is 4. And now I move on to the third column, or the third row of the first matrix. So I have 5 times the first column, 6. Over and down is negative 2 times 0. Over and down, 3 times 1. And over and down, 0 times 2. So I've got 30 plus 0 plus 3 plus 0 for a total of 33. And then the same last row by the last column. 5 times 5. Negative 2 times 2. Three times negative 3. And 0 times 1. So we've got 25 minus 4 minus 9 plus 0 for a total of 12. So that is my final outcome, my 3 by 2 matrix. Let's try another one, and this time we'll show a little bit less of the work. But first of all, is this even possible to multiply? We've got 3 rows by 3 columns, and here we've got 3 rows by 4 columns. Inner dimensions match, so I can multiply these, and I know my result is going to be the outer dimensions. It's going to be a 3 by 4 matrix. Okay, so first row by first column, 1 times 4 is 4. Over and down, 7 times 3 is 21. Over and down, 0 times 2 is 0. 4 plus 21 plus 0 is 25. Okay, first row by the next column. 1 times 2 is 2. 7 times negative 2 is negative 14. And 0 times 14 is 0. 2 minus 14 plus 0 is negative 12. Okay, and then the first row by the third column. 1 times negative 1 is negative 1. 7 times negative 3 is negative 21. Not really sure what's happening to this writing as I go here. And then 0 times negative 10 is 0. Negative 1 minus 21 plus 0 is negative 22. And then the first row by the last column. 1 times 0 is 0. 7 times 1 is 7. And 0 times 0 is 0. 0 plus 7 plus 0 is 7. Okay, so I've got my first row done. There should be 3 rows, and I've got 4 columns already started. So next, I'm going to multiply the second row by each column. So that's negative 3 times 4, negative 12. Negative 2 times 3 is negative 6. And 4 times 2 is 8. So we've got negative 12 minus 6 plus 8, negative 10. Okay, second row by the second column, negative 3 times 2 is negative 6. Negative 2 times negative 2 is positive 4. Negative 4 times 14 is, positive 4 times 14 is 56. Okay, so we've got negative 6 plus 4 plus 56, and that is 54. And then, second row by the third column, negative 3 times negative 1 is 3. Negative 2 times negative 3 is 6. And 4 times negative 10 is negative 40. Okay, so when I combine those, I get negative 31. And then second row by the last column, negative 3 times 0, negative 2 times 1, and 4 times 0, for a total of negative 2. Okay, and then the last row by each column. So this time I'm going to show even less work. 0 times 4 is 0, 0, 2. 0 plus 0 plus 2 is 2. Okay, then on to the next column. 0 times 2 is 0, 0 times negative 2 is 0, 1 times 14 is 14, 0 plus 0 plus 14. Okay, then 0 times negative 1 is 0. 0 times 3, negative 3 is 0. 1 times negative 10 is negative 10. And then the last row by the last column. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. So I've got 0 plus 0 plus 0. And that is my final 3 by 4 matrix. Okay, multiplying by a scale factor. Here's a scale factor of 3. I'm going to multiply this matrix by a scale factor of 3, and that really just means I multiply everything by 3. 3 times 3. 5 times 3. Negative 4 times 3. Negative 2 times 3. 1 times 3. And 2 times 3. That is how you multiply by a scale factor. So here, it's 5 times that matrix. So it's like having a scale factor out here of 5. 5 times 5. 8 times 5. 7 times 5. 2 times 5. Negative 3 times 5. And 11 times 5. So on the last page, we are going to do some matrix operations. We're going to add matrix A plus matrix C. But you know what? Matrix A is 3 rows by 2 columns, and matrix C is 2 rows by 3 columns. I can't add those, because remember, to add and subtract matrices, they have to have the same dimensions. So this is not possible. I cannot possibly add those matrices. Next is B minus D. 2 by 2. And another 2 by 2. Those can be subtracted. So B and D are both 2 by 2, so we can subtract those. So B minus D, we've got 5, oops. All right, there we go. 5, -2, -1, 4, minus 2, 9, -5, 0. Okay, so we've got 5 minus 2, -2 minus 9, -1 minus -5, so that's -1 plus 5, and 4 minus 0. Okay, 3 times A, you can always do scalar multiplication on any matrix. So there's 3 times matrix A, and now we just multiply everything in matrix A by 3. 2 times 3, 0 times 3, 0 times 3, 5 times 3, 1 times 3, and -3 times 3. Okay, then it's 2 times matrix D. So it's 2 times 2, 9, -5, 0, plus matrix B, 5, -2, -1, 4. Okay, so first we're going to have to do 2 times matrix D. So that's 4, 18, -10, 0, plus 5, -2, -1, 4. And now we can add our corresponding elements. 4 plus 5, 18 plus -2, -10 plus -1, and 0 plus 4. All right, and then our last one, 2 times B times D. All right, so we can multiply these in either order. We can do 2 times matrix B, then times matrix D, or matrix B times matrix D times 2, because multiplication is commutative. So let's multiply the 2 matrices first. Okay, so we're multiplying rows by columns. So we've got first row times first column is 5 times 2, which is 10, plus over and down, -2 times -5, is 10, so we get 20. Okay, then the first row by the second column, 5 times 9, and over and down, negative 2 times 0. 45 plus 0 is 45. Then the second row by the first column, negative 1 times 2, and over and down, 4 times negative 5. So negative 2 minus 20 is negative 22. And then the first row by the last column, negative 1, the second row times the second column, negative 1 times 9, and 4 times 0. And that is negative 9. So now we can do our scalar multiplication. 2 times 20. 2 times 45, 2 times negative 22, and 2 times negative 9.